In today's video, we're going to talk about direct variation. Direct variation is the idea that two things change together. So what that means is, as one thing goes up, the other goes up as well. And as one thing or variable goes down, the other goes down as well. Method 1, for direct variation, we can use the formula. K is known as the constant of variation. And in direct variation, K is the same as M. And if you remember, M stands for slope. So K is the slope of a direct variation. B, or the y-intercept, is always 0. So a direct variation is a linear equation where the slope is the constant of variation and the y-intercept is always 0. This means that a direct variation must go through the origin. So examples, we're going to determine if the following represents direct variation. All right, example number 1. I have y equals 5x, and this is in the form y equals slope m or k and then x, so yes, that is going to be a direct variation. The second one, y equals 3/4 x minus 7, this is no, because b is equal to -7 instead of 0. Example 3. At first glance, that may not appear to be direct variation, but it is in fact direct variation because I can rearrange it to put in this formula. So if I have 8x plus 2y equals 0, I can subtract 8x from both sides. And I'm going to write this up here. I end up with 2y equals -8x, divide by 2, divide by 2, and I end up with y equals -4x. So the answer is yes, that one is a direct variation. The last example, I'm going to rearrange this in the same way. So if I have x minus 3y equals 6, I can subtract x from both sides. I have -3y is equal to -x plus 6. Divide by -3, divide by -3. So y is 1/3 x minus 2. And this is going to be not direct variation because b is equal to -2. All right, second way to tell if something is direct variation or not, you can look at a graph. Two things must be true. It must be linear or straight and not horizontal or vertical. So horizontal lines and vertical lines are not direct variation. And number 2, it must go through the origin or the point 0, 0. So examples, determine if each graph is direct variation. Example number 1 is going to be no, because it does not go through the origin.
Please come to the front office. Maggie's Land to the front office.
Example 2, it says yes. My graph goes through the origin and it's a straight diagonal line. Number 3 is also yes, goes through the origin and it's a straight diagonal line. Number 4 is no, for the same reason, it does not go through the origin, or 0, 0. Same idea. Page 2, direct variation. Method 3. You can determine if something is direct variation using a table. In order to do this, we have to divide the y values by the x values. If the number is the same, the points vary directly. 0, 0 will always be part of a direct variation. Examples, determine if each table represents a direct variation. So first thing we're going to look for, we have a 0, 0, so that's good. And then I'm going to divide every y value by x. So k, the constant of variation, has to remain constant, has to be the same number. And then I would divide y by x to make sure that that's true. So -4 divided by 2 is -2. -2 divided by 1 is -2. You don't have to test for 0, 0. 2 divided by negative 1 is negative 2, and 4 divided by negative 2 is negative 2. So yes, that one is an example of a direct variation. So notice I like to just make a third column on that table where you have y divided by x. So same thing here, y divided by x, we're going to test. Negative 12 divided by negative 6 is 2. 4 divided by 1 is 4, and I already have a mismatch, so I don't have to continue any further. No, that's not a direct variation. Last one, y divided by x. Negative 20 divided by negative 5 is 4. Negative 12 divided by negative 3 is 4. 8 divided by 2 is 4. And 16 divided by 4 is 4. So that all works out. I would just need to check to see if 0, 0 would fall on that line. And there's two ways you can do this. You can draw a quick graph, or you can write the equation. So the equation here, if I pick 2 points, I know my slope is going to be 4. So my y value has got to equal 4 times my x value, and nothing's added. So yes, this one is going to be a direct variation. 2 times 4 is 8. Negative 3 times 4 is negative 12. Negative 5 times negative 20 is, negative 5 times 4 is negative 20. All right, now we're going to put all three of those things together. So we're going to find a given value. So steps to find a given value, we have to find k using the equation k equals y over x. Then we write the direct variation equation, y equals kx, and then we solve the problem that's given to us. So example number 1, y varies directly with x. If y equals 3 when x equals negative 4, what is y when x is 2? So we're first going to find k. So I'm going to use the point that's given to me. The point given to me in this problem is 3, negative 4. So my y is 3. My x is negative 4. So k is negative 3/4. So you use the ordered pair that's given. All right? Then I'm going to write my equation. So step 2 is to write my equation. I'm going to leave y in. I'm going to plug in k, negative 3/4 x. That's my equation. And step 3 is to solve the problem. What is y when x equals 2? So using this equation, y equals negative 3/4 x, I'm going to plug in 2 for x. So negative 3/4 times 2. So that's going to give me negative 6/4 or negative 2/3. So my answer would be negative 2/3. So process, step 1, step 2, step 3. All right, number 2. Y varies directly with x. If y equals 9 when x equals 3, what is x when y equals negative 2? So first things first, I find k, and I use the ordered pair I'm given, 9 and 3. So k is equal to y over x, or 9 over 3, which means k is going to be equal to 3. Step 2 is to write the equation where we put y and x back in, and we substitute the number for k, so y equals 3x. And then step 3 is to solve the problem. So I'm using the equation y equals 3x. Y is equal to negative 2. So negative 2 equals 3x. We'll divide both sides by 3. And I end up with negative 2/3 is equal to x. So my final answer for this one as well would be negative 2/3. All right, word problem. Charles' law states that at constant pressure, the volume of a fixed gas varies directly with temperature measured in degrees Kelvin. A gas has a volume of 250 milliliters at 300 degrees Kelvin. What is the volume if the temperature is raised to 420? So the first thing I want to do is figure out what my ordered pair is. When it says the gas varies directly with temperature, you're listing your y first and then your x. Okay? So y varies directly with x. Y varies directly with x. So in this one, volume varies directly with temperature. So my temperature is going to be my x, and my volume is going to be my y. So they always list the y first, volume, and then the temperature is second. So the ordered pair, volume is 250, temperature is 300. So the ordered pair would be 300, 250. So then I can go through. Step 1 is to find K. So K is y over x, so 250 over 300. If I simplify that down, that's 25 over 30, which is 5 over 6. So my K value in this problem is 5 over 6. Step 2 is to plug it back in, so y equals 5 over 6x. And then I'm looking for my volume. My volume was like y. So I want to know what y is when the temperature, or x, is 420. So I would have 5, 6 times 420. So I would simply multiply those two things together and then end up with y is equal to 350. So my volume is 350 milliliters of gas. Little high school chemistry for you related to 7th grade math.